Hello, and welcome back. During today's lesson, we are starting our newest topic about probability. And so today we'll be learning what probability is and how we can determine the probability that something is going to happen using words and fractions. And so your objective today is to be able to describe the likelihood that an event will occur using words and numbers. And I want you to be thinking about how is a probability related to the study of ratios. So we're thinking a long time ago during topic 2 when we used ratios to solve problems, and that's what we're going to be doing today. In the do now, it says for a game show, Jared has to choose one of 8 boxes to win a prize. One of the boxes has a big prize. 3 boxes have a medium prize. 3 boxes have a smaller prize, and 1 box is empty. How confident should Jared be that whatever box he chooses, he will win a prize? And we have to be able to support our argument. So that's what you're going to do over here. You're going to, on your own, you're going to write down how confident should Jared be that whatever box he chooses, he'll win a prize. So you'll say whether or not he should be very confident, it should be certain, it should be a guarantee. He shouldn't feel certain, it's not going to happen, different words like that, okay? And then what changes could be made to make him even more confident than he already is. So those are 2 things that you're doing on your own. When you're done with that, you can resume the video and flip over to the next side. So in the first example, it says Alyssa and Sherry spin the pointer to the right and record the color that it lands on. The table shows their results after 100 spins. How can Alyssa and Sherry explain the results? So you get the 4 colors. This is how often they happened. You can see they're all pretty close to each other. Green happened the most, but not by a lot. So there are 4 possible results or outcomes when Alyssa and Sherry spin the pointer. So I'm going to circle this word again and circle the word results because those mean the same thing. So the pointer could land on a red section, a yellow section, a green section, or a blue section. And each section is the same size. And there's 1 section of each color. So each of the 4 outcomes is equally likely because the pointer has an equal chance of landing on any of these 4 sections. Each time they spin the pointer, the likelihood or the probability, so that's a new word for us. The probability is the same thing as the likelihood, which means how likely it is something's going to happen. So each time they spin the pointer, the likelihood or probability of the pointer landing on red, yellow, green, or blue is the same. Each of the equal size sections is shaded 1 of the 4 colors. So the probability of the pointer landing on any given color is 1 out of 4, or 1/4. Since 1/4 is equal to 25%, the probability can also be written as 25%. So let's circle this 1 out of 4, and then circle 1 out of 4, or 1/4 as a fraction, and then circle 25%. So these are all 3 ways that we can write probabilities. So the spinner has 4 sections. Each section is shaded 1 of 4 colors. The pointer should land on each color about 1 out of 4 every 4 times, or about 25 times out of 100. So 25 times out of 100. And if you look back up here, so all of these are pretty close to 25. Again, just a little under and a little over, but they're all really close to 25. So how might the probability of the pointer landing on a given color change for the spinner shown at the right? So notice how this spinner has more sections, but it's also the same colors. So there's 2 greens, yellows, 2 reds, 2 blues. And since these are all the same size, we can kind of rearrange these in our brain to think about this being blue, this being blue, this being yellow, this being yellow, this being red, and this being green, this being green. And if you think of it that way, each of these is still making up the same size that it was making up before. So the probability is not going to change. How would the probability of the pointer landing on a given color change if the spinner had 6 equal-sized sections with each section of a different color? So with the old spinner, the probability was 1/4 or 25%. With this new spinner, since it has 6 equal-sized sections, it's going to be 1 out of 6. Ali is going to select a card from the group of cards shown. Complete each statement. When Ali picks a card, what are the possible outcomes? So remember that the word outcomes means the same thing as the word results. So what are the different results? So she could pick a 1, a 2, a 3, and a 5. What could Ali do to make picking an even number more likely? You're going to answer that one on your own. So you're going to think kind of like what you did during the do now. You're going to think about what is it that Ali can do to make picking an even card more likely. When you're done, you can join me on this section down below. So we can use words like impossible, unlikely. So impossible, unlikely, equally likely, likely, and certain to describe the probability of events. So if there is a 0% probability that something's going to happen, we would say that it's impossible. Anything from 0 to 1/2 we say is unlikely. When we have a 1/2 probability, we say equally likely. When something is greater than a 1/2 probability but less than 1, we say likely. And when there's a 1% or a 100% rather probability, we say that the event is certain to happen. So the probability of rolling a number less than 7 is 6 out of 6 on a number cube. So that's a probability of 1. So we say that's certain. When you flip a coin, the probability of landing heads up is 1 out of 2. So that event is equally likely to happen. And the probability of rolling a 7 on a regular dice is 0. So that would be impossible. So now you're going to practice using those words and numbers to find probabilities of different events. So you've seen this before. it says we're going to describe the probability of each of the following using words impossible, unlikely, equally likely, likely, and certain. So the likelihood of picking a 2, it's not certain, likely, or equally likely, and it's not impossible, so we would say it's unlikely. Now you're going to answer this question and this question on your own, and then join me down here when you're ready. Alright, so we're going to be using probability and likelihood to describe situations. Here are some examples. Carrie's going to roll a number cube with sides labeled 1 through 6, so it's just a regular dice. The probability that she will roll a 2, so there's only 1 2 on the dice, so it's a 1 out of 6 probability. The probability that she'll roll a number that's less than 7, so all the numbers on the dice are less than 7. So that's a 100% chance, or a 1 out of 1 or 6 out of 6 chance of rolling a number that's less than 7. And rolling a number that's greater than 6 is a 0% or an impossible. What would I say here? What would I say for something that has a 1%, a probability of 1? We would say that that's certain. And if something has a probability of 1/6, we would say that's unlikely. Okay. So for the following problems, you're going to do much of this on your own, but I'm going to do an example for you so you see what I'm looking for. So it says this game piece here has 12 sides. It's labeled numbers 1 through 12. So the probability of rolling an 11. Probability of rolling an 11, there's 1 11 on the dice out of 12 total sides. So we're going to say 11 twelfths, and then we're going to say likely. So for this one, you're going to have a number answer and then a word answer. Same thing here, a number word combination. Same thing for these problems. You're going to have a number answer and then a word answer. And these are both on your own questions. So you'll show those to me when you're done. Lastly is this idea of fairness. So how can we tell if an event, or in this case a spinner, is fair? It says Marisol designed a spinner for a game. The spinner is fair if there is an equal chance for the pointer to land on each number. So I'm going to underline that. The spinner is fair if there's an equal chance for the pointer to land on each number. So let's see what happens here. Well, not really numbers, we've got letters. But does every letter have the same chance of being picked? No, because we've got 2 sections that have A, and everyone else has just 1 section. Every other letter has 1 section. So because it's more likely that you're going to land on an A than it is any other letter, this is not a fair spinner. This one, it's hard to see on your copy, so check that out. Is this spinner fair? And if yes, explain why. And then if not, describe a change that could be made to make the spinner fair. So this spinner is not fair because there are 3 colors. 5 of the sections are blue, 4 of the sections are red, 1 section is blank or white. So no, this is not fair. So you are more likely to land on blue than you are to land on red or white. Okay, so now you're going to go ahead and practice this question and then this question. There is no summarizer, so you're going to show this to me when you are done.